Hi guys, welcome to today's class, still on motion. We have actually taken problems on different types of motion, and today we're taking problem on another different type too, called projectile motion. So in projectile motion, a lot of us who actually see the projectiles are used in different ways and different forms. A lot of us who actually like seeing war movies, action movies, you see maybe sometimes they fire some weapons like RPG and all the rest of that from a particular distance to a particular distance. Or before such are done, they calculate this projectile motion to calculate the range and the distance with which the fired bullet will get to before it is done. So those are some of the importance of or usage of projectile motion and so many other ones. We'll be taking problems on them, probably some of them will be coming up. Now we have here that if we have, say, a body like this, maybe let's call this y-axis and this is s-axis. Probably a bullet is fired like this. Discover that it will get to a particular height called the maximum height. At that height, it can no longer go further again because it will be acted against by gravity, and it will start falling until it got back to the ground from where it is fired. Now, the point from which it is fired from, it has what we call initial velocity, which we know as v naught, just as it is when we did the vertical and the horizontal motions, v naught, and this is angle theta, the angle it forms on where it is being fired, and this is v naught x on the x-axis, and this is also v naught y on the y-axis. Okay. Now, if we are to resolve this, we have that v naught y over v naught we have equals to v naught sine theta. Now we have that v naught y is equals to v naught sine theta. We also have here that v naught x on the x-axis is equals to v naught cos theta. Now that is resolution of the operations that is happening in this place, v naught y. Now, but this is not really the formula to solving projectile motion. I will write down some of the formula so that whenever we want to solve any problem in projectile, you can just from knowing what is given, we will know exactly the particular solution, the particular formula to use. Sorry, let me maximum time of a projectile motion. They call it maximum time of projectile motion. It is called as is equals to v naught sine theta over g, acceleration due to gravity, or just like in horizontal, 1 naught sine theta over g. That's maximum time. We also have what we call total time. Total time here is here t is also 2 times t mass. That the total time is 2 times the maximum time. It's also represented as t equals to 2 v naught sine theta over acceleration due to gravity. The third one, we have what we call the maximum height. Right, 2 is 3. The maximum height with which a body fired can go. Maximum height represented as y mass is equals to v naught square sine square theta over 2g. That's 2 times acceleration due to gravity. We also have another one, the range with which the body, a fire body can go. It's represented as x is equals to v naught square sine 2 theta over g. Acceleration due to gravity. I also have what we call, but the maximum range where angle theta is equals to 45 degrees is S mass equals to V naught square sine 2 times 45, that's 2 theta. Therefore, S mass here is equals to V naught square sine 90 over G. And this can also be S mass equals to V naught square over G. I think as we begin to solve problems, we'll be calling them out one by one, and I will see how it is done. Thanks for watching, and watch out for how this formula is being used in our next class. The reason I brought this up so that once a question is brought, as my student, you can already guess or assume the type of formula with which we use in solving the problem from the question. See you in the next class. Bye.